Okay, today let's talk about partial fraction decomposition. Okay, and what that means is if I have a rational function, how can I write that rational function as a sum of two simpler rational functions? That's what partial fraction decomposition means. In order to do that, I need to be able to factor the denominator. And when I factor a denominator, I have several possibilities. I could get non-repeating linear factors of the form, for example, ax plus b or x minus a or something like that. I could also get repeating linear factors, which would be linear factors that have powers on them. And I could get non-repeating irreducible quadratic factors. Okay, and each of those situations is going to be treated a little bit differently. We're going to be doing three parts to this podcast on partial fraction decomposition. And part one, which is where we're going to start here right now, is going to deal only with non-repeating linear factors. Okay, all non-repeating linear factors, for example, ax minus b, of the denominator will have a decomposition term of this form right here. Some number divided by the non-repeating linear factor. Okay? For example, let's decompose this rational function into its partial fractions. I need to first factor the denominator. So here it is again. This is my rational function with a factored denominator. Here I see one non-repeating linear factor and another non-repeating linear factor. So each of them is going to have a term of that general form there. For example, here's my rational function. Here's the first partial fraction decomposition term, some number over x plus 1. Here's the second term, some other number over x minus 4. And what I want is to find a and b such that this equation is true. Okay? And what I'm going to do to start that is, now here's my equation again. This is the one that I'm looking for. What I'm going to do to figure this out, what a and b equal, is I'm going to start by multiplying both sides of the equation by this denominator. And here I have it right here. Okay? Multiply both sides of the equation by this denominator over here. This denominator will cancel with this denominator, and I just get 5x minus 5. Over here, when I distribute this multiply here to the first term, the x plus 1 will cancel with the x plus 1, and I'm just going to get a times x minus 4. When I distribute this to the second term, the x minus 4 will cancel with the x minus 4, and I'm just going to get b times x plus 1, and here it is b times x plus 1. Now I'm going to distribute in and rewrite so that I get my x's together and my constants together. And here's the deal. Okay, when I have an equation like this, the coefficient of x over here has to equal the coefficient of x over here. So I'm going to get 5 is equal to a plus b. And the constant term here has to equal this constant term here. So negative 5 has to equal negative 4a plus b. And that gives me two equations in two variables that I can rewrite as a system of equations. Now at this point I can use any method at my disposal to solve this system of two equations in two variables. I can use elimination, I can use solve for one variable and use substitution. I can use any of the matrix methods that are at my disposal as well. And when I do that, I find that a is equal to 2 and b is equal to 3. That would be the solution to this system of equations. So plugging back into my original equation, plugging in 2 for a and 3 for b, I get this partial fraction decomposition of my original rational function.